In this video, I'm going to show you how to take an arithmetic sequence, find the explicit formula for that, and then find any term that you want using that explicit formula. I'm going to start with the same sequence I've used before, -10, -15, and -20, and so on. And I'm going to use it to find the 72nd term. Kind of just created that on the fly, so just picked that number out of my head. Now, if I'm going to do this, I need to go back and look at my original equation for an explicit formula for an arithmetic sequence. And I'm going to start by writing the ideas first. So you want the difference. You're going to multiply that times whatever term number you're looking for, minus 1. And you're going to add that to where your sequence starts. And that will give you the term number you're looking for. So the term you are looking for, or you're finding. So that's the basic idea. Written in variables, it looks like this. D times the term number, which is n, minus 1 plus the start, which we call A1, and that equals A sub n. Now, if this is my original form right here, I need to find those different pieces from that formula. So, the difference between each one of these is minus 5. In other words, I have to subtract 5 every single step in order to figure out what the next step is. So for this problem, my difference is going to go right here, and that's minus 5. Now, my term number that I care about, in this case, is 72. So this goes in there for my n, and it goes in two different places. One there, and one right there. So it's my 72nd term, minus 1, plus A1, which in this case is my start. So that's the number that goes here. And that's going to give me my final number, which in this case is A72. Now I just go through and I use PEMDAS. So those of you who don't remember, please excuse my dear Aunt Sally. That's the order you have to do all your arithmetic in. And you start off here with P, which stands for parentheses. So I do everything inside my parentheses first. 72 minus 1 is 71. And that's going to be multiplied times my growth, or my difference, which is -5. And I'm going to add on to that my -10. And that'll equal my A72, or the 72nd term of my arithmetic sequence. Now I'm going to need to use a calculator for this one. So, actually I don't need to use a calculator, I kind of just did it in my head. This should be -355. And that's going to be added to still my -10. And that's equaling, and -355 plus a -10 ends up being -365. So that is my answer, A72. So my 72nd term is -365. And if you see where all the different connections were made between here, you see how this difference right here is my D, this starting point is my A1, and the 72nd term is the one I'm looking for, so that's my n that I put into my equation. Now these arrows are also part of are an important thing to recognize because they show you where the ideas for these variables come from in my actual problem situation. And learning how to make those connections is one of the most important things you can do in algebra. So don't just do the math, make sure that you understand why you're doing each and every piece of it. So there's how you can turn a sequence into an explicit formula and use that explicit formula to figure out any number that you want, any term that you want in your sequence.